Stand on Mars tonight and your home would look like a bright evening star. Travel to Saturn, and every ocean, city, and person on Earth shrinks into a single blue pixel. Go even farther, and Earth disappears in the sun's glare. So what does our planet actually look like from every world in the solar system, and where do we lose sight of home completely? We start just 3 days away at our nearest neighbor. From the dusty plains of the moon, Earth is the undisputed star of the sky, hanging like a giant, glowing marble that is roughly 3.7 times wider than the moon appears to us. Because the moon is tidally locked to Earth, our planet never actually rises or sets. It stays anchored in almost the exact same spot in the dark sky, only performing a tiny, slow wobble called libration. Instead of a dead rock, you are looking at a living canvas of swirling white clouds and sweeping blue oceans spinning every 24 hours. Even better, Earth's phases run completely opposite to ours. When the moon is pitch black, Earth is fully illuminated, washing the lunar surface in a blue glow. It is easily the greatest screensaver in the solar system, though the Wi-Fi is incredibly disappointing. Mercury strips away the comfort of a blue sky. Because this scorched world has virtually no atmosphere to scatter light, its daytime sky remains pitch black. Above the horizon, the sun dominates the view, appearing up to 3 times wider than it does from Earth. Spotting our home planet against this blinding backdrop is like trying to find a phone flashlight glowing right next to a massive stadium floodlight. Yet, the geometry occasionally aligns. On May 6, 2010, the Messenger spacecraft captured this alignment, snapping a portrait of Earth and the Moon as 2 distinct, bright pixels from 183 million kilometers away. At this first stop, finding Earth is no longer a challenge of distance. It is a geometry problem, a game of cosmic hide-and-seek played beside a giant, blazing spotlight. Venus takes a different approach to ruining the view. It hides everything behind a suffocating blanket of clouds. From the surface, those thick sulfuric acid clouds block any view of Earth, turning even the sun into a faint, featureless smear. Standing down there means dealing with a crushing environment. The temperature hovers around 465 degrees Celsius, and the atmospheric pressure is 90 times greater than Earth's sea level. It is a bizarre world where the planet rotates backward, and a single day actually lasts longer than its entire year. If you could somehow rise above those choking cloud tops, Earth would shine as a brilliant point of light, far brighter than Venus appears to us. But from the ground, the view is completely canceled. Venus easily claims the title for the worst observation deck in the solar system, and there is absolutely no refund desk. Mars delivers the first real look at Earth as a star. On January 31, 2014, 80 minutes after sunset, NASA's Curiosity rover pointed its camera toward the Martian twilight. From a distance of 160 million kilometers, the rover snapped a picture of a tiny, brilliant speck hanging over the horizon. That speck is Earth, shining brighter than any actual star in the Martian night sky. Just below it sits another, fainter point of light, our moon. NASA confirmed that a human standing on the red dust with normal vision could easily see both as 2 distinct, glowing evening stars. Future astronauts on Mars won't need a telescope to look back at their home. They will only need to look up. Every ocean, every city, and every single human conversation is packed into that one brilliant pixel. Jupiter offers absolutely nowhere to stand. To even attempt to look at Earth from the king of the solar system, you have to park your spacecraft near one of its icy moons or brave the planet's lethal radiation belts, which would fry standard electronics in a heartbeat. From this hostile vantage point, the scale difference is staggering. More than 1,300 Earths could fit inside Jupiter's massive volume, yet from here, our home planet is reduced to a microscopic speck. Because Jupiter orbits so far out, Earth never ventures far from the blinding glare of the sun. Without powerful telescopes, trying to separate our home from the solar glow is like looking for a stray glitter flake next to a searchlight. The solar system's largest planet ironically gives Earth one of its smallest, most frustrating cameos. Saturn shifts the scale from abstract numbers into something surprisingly personal. On July 19, 2013, The Cassini spacecraft slipped into the shadow of the giant ringed planet and pointed its camera back toward home, nearly 1.4 billion kilometers away. The resulting photograph, known as "The Day the Earth Smiled," captured our entire planet as a single, pale blue pixel nestled beneath Saturn's glowing E-ring. The raw spacecraft photograph shows the moon as a faint second speck of light right beside it. But what makes this specific portrait different is that for the first time, humanity knew the picture was being taken. People across the globe were invited to step outside, look toward Saturn, and wave at the exact moment Cassini's camera snapped. From this distance, every ocean, every continent, and everyone who has ever watched a sunset is compressed into a single pixel, framed by millions of kilometers of icy rings. Here, cosmic scale stops feeling like an astronomical abstraction and starts feeling intensely personal. Uranus takes the difficulty of spotting Earth and turns it sideways. Literally. The planet has a bizarre 98-degree axial tilt, meaning it effectively rolls around the sun on its side like a cosmic bowling ball. This extreme tilt creates winter and summer seasons that drag on for roughly 21 Earth years. But even if you waited 2 decades for the perfect night sky, you still could not see our home with the naked eye. From this frozen world, Earth is a microscopic, incredibly faint point of light huddled dangerously close to the sun. Capturing it requires a powerful telescope and specialized equipment to block out the blinding solar glare. At this distance, our home is no longer just far away, it is practically invisible. Neptune sits about 30 times farther from the sun than Earth does, orbiting in a frozen twilight where daylight is roughly 900 times weaker than what we experience. Yet, even in this dim environment, the sun remains bright enough to completely overwhelm our home planet. To the naked eye, Earth is completely invisible from here. Spotting it requires powerful telescope optics and precise mathematical positioning, a challenge equivalent to trying to resolve a tiny firefly buzzing right next to a massive headlight. Because no spacecraft has ever photographed Earth from this distance, any visual representation of this viewpoint is strictly a computer simulation. At this extreme boundary, the vibrant blue planet is officially lost to the dark. Pluto averages about 39 times Earth's distance from the sun. At this lonely frontier, daytime is much dimmer, yet the sun still appears as a brilliant point of light in the cold sky. To the unaided human eye, Earth is completely swallowed by that solar glare, lost to the dark. But we have real, photographic proof of our existence from the deep. On February 14, 1990, NASA's Voyager 1 spacecraft turned its camera back home from 6 billion kilometers away, far beyond the orbit of Neptune. It captured the iconic pale blue dot image, showing our entire planet suspended in a scattered beam of sunlight. In that quiet, precise frame, everything we have ever known occupied less than a single pixel. As we prepare to step onto other worlds, these distant views serve as our ultimate reality check. From here, Earth feels endless. From out there, it is barely a pixel, and somehow, that pixel is everything. Subscribe to Astral Nexus HQ for the next journey.